Coffee. Hello and welcome to today's live stream. I think that's the first live stream of 2022. Welcome to it. So today we're going to get started right away. I've prepared a talk and I got a question about this recently and I went on so long answering it that I thought that it would be best to make slides. So I did, and here we are. Oh, one second, let me make sure I've got the chat visible so I can talk to y'all as needed. Okay, and we are good to go. Fabulous. And I'm hoping that we won't have any more connection issues today. So the question I got was basically, hey, can you tell me what the best chatbot framework is, basically, more or less? And they were asking for, some sort of basically a theoretical guarantee of things like performance. And if you're coming from a background where you're working with something, say, like databases, where you can get a theoretical guarantee of, retrieval speed given held variables, I think that's a very reasonable ask. But chatbot frameworks are a little bit different. Hey, Chris, welcome. So why is there no best chatbot framework? Well, the best chatbot framework for you depends. So there's a very, I don't know whether or not it's funny, I'll let you decide that, but there's a joke that, if you ask a senior engineer a question, they'll always answer, it depends. And it does depend. What the best chatbot framework is depends on your specific needs, like what you want to be able to handle, and also your specific training data set, particularly in a machine learning setting. So that's the talk. Thanks for joining in. I'm going to head out. No, the rest of the talk is going to be going a little bit more in depth on some of the things that it depends on. So this is not a comprehensive list of everything you'd want to consider. But if you and I were sitting down and talking about a chatbot that you wanted to build, these are some of the things that I would ask you about, and that providing information about would help you understand what sort of system you would need given your situation, your unique set of circumstances. So first off, the problem. And I would say the number one biggest mistake people make when they decide to build a chatbot is not having a problem that a chatbot will solve. And I think this has not been as much of a problem currently, but certainly in, say, the 2016 era, that big boom when everyone was building a chatbot for everything, a lot of those chatbots did not need to be chatbots. So the very first question I would ask you are you sure that you need a chatbot? What specific problem are you trying to solve that you need to have a conversation with somebody to solve? And not having a chatbot is not a problem in and of itself, right? It should be doing something that you need a chatbot to do. So some specific signals that if you are seeing this in your organization and your life, you're just building a chatbot for yourself, things that are like, yes, this is a good use for a chatbot. Are you having repetitive conversations, or is somebody having repetitive conversations? So this is why support can be a great place to have a chatbot if the majority of conversations are about 2 to 3 topics and tend to be mostly the same. If you can handle those automatically, people get a faster experience, you save time and effort, and then you can save your valuable expert resources for the more complicated or more unique questions. If people aren't already having conversations or don't know how to have a conversation to perform a task, maybe it's a form and you don't need a chatbot. And the second thing to think about is if you want your chatbot to do something, is the information they're going to need to interact with already machine readable, or can it be made machine readable? So a great example here would be, I have had many jobs in my life, and one of them was I worked in a bookstore, and the bookstore had no, computerized inventory system. So if someone wanted to know if we had a book, they had to call in. I'd answer the phone, I'd put the phone down, I'd go and I'd check on the shelf physically to see if we had that book, and I'd come back and be like, yeah, we have it. No, we don't. That's a system that you can't build a chatbot for without beforehand doing so much additional work that the chatbot is, moot at that point. There is no way for people to interact with this system in a human is standing there looking at things sort of way, right? So that could be, the data that you need to perform your task, or it could also be the training data that you need. So if you have a bunch of, say, chat logs, but they're all in, just as an example, PDFs, That's going to be quite a challenge to take that and make that into usable data that you can, um, use in your machine learning application. So things to think about. Also, do you know what success or failure looks like? Can you measure it? When will you know if your chatbot has done a good job? When will you know if you have successfully done the thing that you set out to do? If you can't define this, um, probably from a product perspective, you should take a step back, but also, machine learning works through optimization, and it's optimization of some function, and that function needs to be provided. So you need to know what you're optimizing towards. And if you can't articulate that or operationalize it in some way, you're never going to be able to machine learning it, right? If that makes sense. So, no amount of machine learning know-how or expertise will solve the fundamental problem that you don't need a chatbot to do what you're doing. So, and we talked about this a little bit with Lauren in Office Hours on Wednesday as well. Also, the rendered video of that is much more watchable than the live stream was due to technical issues. But if you're sure that you need a chatbot and that's going to solve your problem, and you've got everything that you need to do, the next thing to really start thinking about is training data. So if you are only using rules for your chatbot, both for determining what people are saying and directing the conversational flow, so this would be something like a system where I call in and I say, here are your options. Press 1 to talk to, Michael in sales. Press 2 if you want to file a complaint, or whatever it is in your tree. You don't need training data for that. Perhaps obviously the majority, I don't want to say the majority, but a lot of chatbot platforms and frameworks these days are going to be based on machine learning, and you will need training data. And if you don't need to provide training data and it's a machine learning system, someone else needs to have provided that training data, and you want to make sure that those things are a good fit for each other. Because if I train on, say, just an example, if I change a chatbot on Shakespearean plays, and then I am trying to use it with modern consumers who are trying to return an iPhone, that's going to be a pretty big domain mismatch, and I think you're going to have some pretty unhappy users when they try to use this chatbot. So some questions to ask about your data. Do you have enough data? And generally, the more diverse your use case, the more unpredictable things are, the more instances you're going to need to predict them. Do you have too much data? And this may seem like a non-problem, particularly if you're coming from a background where you haven't worked with a lot of big data sets. But you can sometimes get in a situation where you have an enormous amount of data, only some of it is relevant to your problem at hand, and you have no way of knowing which. And that can be, an enormous and perhaps insurmountable data engineering challenge within the confines of the time and compute that you have. If you do have data, how easy is it to get? You have to, get somebody to ship you a hard drive from Indonesia. That's much more difficult than I can download it from our shared cluster. If it's getting updated over time, are you going to have access to those updates? How easy is that for you? How much time will that take? Do you know what data quality means? So if you were sort of adjacent to data science or doing data science, you're of course familiar with data cleaning. And the sort of general idea there is that the data you get probably is not in the format or has things in it that you're not interested in. How do you get only the things you're interested in the format that you need to do whatever else is in your pipeline? Can you answer those questions? How do you know when you have gotten there with your data? That's not trivial. Data engineering is, a discipline in its own right. And just because you maybe have some chat logs doesn't mean all you would need to do is just feed your raw chat logs into the machine and you'll get a chatbot out. It would be great if that's how it worked, but it just does not. That's a magic trick that I would love to learn, but it's just not doable. So no amount of machine learning will get you out of data cleaning. You may be getting the sense that machine learning is maybe the minority of the things you'll be doing when building a chatbot, and that is the case. So speaking of machine learning, turning a little bit more to the machine learning side of things, different problems will be different amounts of tractable, right? So given your specific data set and your specific goals, a machine learning problem might be very trivial, right? Like any baseline is going to be good enough. You don't need to do a lot of fancy work to get you there. And in fact, doing a lot of fancy work is just a waste of time. It may be difficult but doable. So with a lot of machine learning work and time and effort, you might be able to get, Probably not incrementally improving. You're probably going to get a big jump and then smaller jumps over time as you get towards ceiling. Ceiling would be the highest theoretical limit of performance in your particular problem, whatever that is. And this would be like a Kaggle competition would be a good example of this type of problem. These are pretty rare in my experience. I'd say maybe, I don't know, 10% of problems, roughly in there. I'm just making up a number. And then finally, impossible. And these are the types of problems that it's the most heartbreaking because given your goal and the data that you have, you just cannot answer your question. So a great example for this would be I was, met with somebody a while ago, a couple of years ago, and they were interested in trying to find information to identify court cases that might be overturned. And they had a lot of data from their standpoint, like they spent a lot of time and effort collecting it, and they had 50 data points. And they wanted to be able to predict what court cases might be overturned in the future. And it just wasn't enough data. Like the features that they had and the number of data points that they had and the complexity of the question were so mismatched that machine learning would not have provided any benefit there. It would have basically been a waste of time to try. And again, if that's your case, then a machine learning approach is just not going to work for you unless you change your question fundamentally or you get more or different data so that you can answer your question. And then other sort of things that will make it more or less tractable. So if you are doing a chatbot with machine learning, particularly if you're training your own intents, those intents will exist in some sort of n-dimensional feature space, and that'll depend on your particular implementation. But if given your feature space, your intents completely overlap, there's no way that you can like draw a circle around only the intents that you want for a given label and leave out the other ones, right? So this is a very convoluted example, but stick with me. One thing that I like to compare it to is if you've ever had Jell-O. It's a type of flavored gelatin. It's pretty popular in the US. And some people will make it with fruit in it. And again, so imagine here the little pieces of fruit in the Jell-O are the data points. And for some types of Jell-O, you might be able to say, the pineapple's all on this side, the pear's all on this side. I can clearly separate these two. But for others, you might have the pineapple and the pear completely intermixed, and there would be no way to create some sort of shape that would separate those two and only those two. And if that's just the way that you have it, you probably need to redesign your intents, is the approach that I would take there. Do you have the right number of intents given your underlying target distribution? So again, thinking about if I'm trying to cluster things in my Jell-O, if I have 3 distinct groups and I try to turn that into 4 distinct groups, I'm going to have to draw 4 shapes trying to capture 3 actual shapes that really exist, if that makes sense. So if you're not capturing the right number of intents that are represented in your underlying data, you're going to have a real hard time of it. Is there a lot of ambiguity? So ambiguity is something that can mean 2 things. So that could be in syntactic structure. You probably won't have to worry about that for chatbots unless you're really in the weeds. Or it could be things like words, or it could even be people using multiple words to refer to the same type of topic or structure or thing that you're interested in. Particularly if you have a customer-facing chatbot and you have, internal terms, somebody may or may not ask for the specific service that the way that you would have called it. They might use their own words, and you might be trying to map those and reach some ambiguity there. The more ambiguity, the harder. If there's too much ambiguity, again, it's intractable. In terms of conversational flows, the way you want the conversation to go, do you have enough? This may be something you train. This may be something you design. You may need to, hire conversational designers to write these for you. And just as an aside, in Rasa, if you're providing training data, you can use Rasa data validate. That's a command line command, and we'll tell you if there's anything that's contradictory, and you can fix those. But if you don't know what your conversations are supposed to look like, you will have a really hard time having those conversations. So that's all. Is your underlying data, are there patterns in it that are actually learnable? And I can't tell you that without spending a lot of time sort of digging down into the data set. Now let's talk about models. And I think this is where things tend to become really unintuitive if your background is not in machine learning, if you're coming from, say, something like databases. I just use that as an example because I like databases. So what model will work for your data set? In general, as sort of a general principle, the more parameters a model has, the more subtle the distinctions it will be able to learn. So if you can think about it like connect the dots, the more dots that you have, connect the dots is like it's a children's game. I don't know how popular it is around the world, but basically there's a bunch of dots and you try to like draw lines between them and you make, oh, it's a giraffe holding a balloon or whatever the shape is. And the more dots there are, the more fully outlined the shape is. If these dots are parameters, the more complex a shape you can capture. Just to give you sort of an intuition, it's not one-to-one, but it'll also be more flexible, right? It'll be able to handle new things that it hasn't seen a little bit better in general. But it'll also take longer to train because each of those parameters is going to need to be updated. That takes time. And the more data is required. So a really good example of this would be something like if I'm trying to teach you the difference between, grape juice and apple juice, and you have, a normal olfactory system, I probably only need to give you, 1 or 2 samples of each, and you'll be able to pick up on the difference between those tastes really well. But if I'm trying to get you, to identify specific, specific notes in a wine pairing, right? Or like be able to pick out really individual flavors, I'm going to need to give you lots of examples. And you'll need to try, 8,000 different wines or something like that in order to develop the ability to make those distinctions. And in general, more parameters will be better at that. So an example of a type of model that has a lot of parameters would be transformers. They've got a lot of parameters. And we have a couple different videos on our channel about transformers and the architecture if you want more details there. And then on the very low end, you'd have something like simple regression, y equals mx plus b, where you have 2 parameters, the slope and the intercept of the line. So just sort of, that's the range you're working in if you're looking at machine learning models. With that said, I've been speaking in sort of generalities and not specifics because the fact of the matter is with current machine learning methods, particularly deep learning methods, neural networks, we just don't have a lot of specific guarantees that we know about yet, right? The field is still pretty young. That's not fair. The field's been around for a while. It's only been like practical for not that long. And yeah, I can't tell you what a model's going to do before I train it. And I can't give you many, if any, formal guarantees about the behavior of a model before I actually sit down and train it with the data. And in general, the newer the architecture, the less we know. So transformers, date to 2017, they're fairly new. We don't have that much, formal theoretical understanding of how these models work in terms of internals, which means there just aren't that many guarantees because we don't know them yet. That doesn't mean they don't exist. It just means that we don't have that knowledge as a field. Also, there's a lot of degrees of freedom in terms of training a machine learning model. So a machine learning model is not just the architecture. It is a specific architecture and also the specific data set that you've trained it with, and also the specifics of the training. So things like how you initialize your model, what your random seed is, how many epochs you train for, the split of your data into testing and training and validation. All of those things will affect the final model. So if you've heard of replication in machine learning, that's the idea of trying to fix as many of these parameters as possible so you get, the same model twice. And even then, particularly if you're using GPUs, it's not necessarily deterministic, which is, again, if you're coming from other parts of computer science, might be like deeply weird to think about, but that's the way machine learning is. And I can't tell you what changes will change the model a priori, right, beforehand. I can sort of, the bigger the model, the more the data, the more you train it, the likely better it is to be, but maybe not, right? I can't tell you until you try it. And the state of the art in machine learning development is really guessing and testing. So trying a new architecture, training it up, using specific parameters, maybe do some ablation training, removing things, see how that changes stuff, and seeing what happens. And this can be very unintuitive. And then other very specific concerns for model selection. So one is over-parameterization. Do you have so many trainable or learnable parameters that you are basically you don't have enough data, or you don't have a complex enough use case that you don't basically immediately overfit, right? And this is going to be relative to your data or your use case, but as a general rule of thumb here, if you have a simple problem in a small data set, you shouldn't use a model with a lot of parameters. It'll be a waste of your time and energy, and you'll end up with something not very useful. Transfer learning versus training from scratch. So a lot of the large transformer language models were developed with the idea of being part of a larger machine learning pipeline or NLP pipeline. And I can't tell you which is going to be best for your project necessarily, particularly for Rasa assistance. Especially not for English. There is some research evidence from folks in our communities that training from scratch might be better than transfer learning. There's a paper on Vietnamese that I think is particularly useful there. And the degree to which, transfer learning is helpful is going to depend on how close of a match there is between the data that the transfer learned model was trained on and your specific data, and also just sort of generally how the problem's formatted. So something else to consider there. Fox says, best slides. Oh, thank you. Another thing to think about is latency. How long does it take for your model to give you a prediction at inference time? So not during training, but like once your model's trained, deployed, how long does it take for your model to get back to you? And you're like, here's some data, request, give me a prediction. In general, for voice applications, the lower the better. You don't generally, say something in a conversation, wait a little bit longer, and then have somebody get back to you. It's usually pretty fast. Whereas in text-based applications, we are used to waiting for people to type, so a little bit slower is not as much of an issue. One thing I've seen people do in voice applications that I don't especially like, but maybe other users do, is that they'll play typing sounds, like they'll pretend that the chatbot is typing to cover the latency of the model. So that might be a strategy that works for you. And then also retraining. So how often will you need to retrain your model? Something that's very central to the Rasa chatbot framework is that we assume you're going to be retraining often and you're going to be redeploying often. And as part of that, we've done a lot of sort of architectural work to try and make retraining faster, using like checkpointing, and our new graph architecture that's new in 3.0 is really, decreasing training time for training the model once it's already been trained is a big goal of that. Because we have, many people in enterprises build very large Rasa assistants. We want to make sure that they are as efficient as possible for retraining. The more parameters, the longer it'll take, just as a general rule of thumb. All right. Next up, logistics. And this is the least machine learning specific slide, but also unfortunately the one that's probably going to be most impactful for people that are picking frameworks. The specific logistics that you have that, are going to affect the choices that you make are just not universal, right? So I can say, even if I could say on a machine learning standpoint, which I can't, like this is the absolute best framework, this is the best architecture, given your data set, I couldn't necessarily guarantee that you'd be able to implement and deploy it, right? So just some things to consider. Do you need network access? Sorry, I had a hard time reading that. Do you need network access? If you've got an air-gapped system, you can't use cloud computing. So I might have, the world's best, most perfect, the platonic ideal of a chatbot framework, but if you can't use cloud computing and it requires cloud computing, oh well. Or, inversely, you may need a system that's very distributed and available everywhere, and maybe cloud computing makes sense for that, and hosting it on-prem would be a huge pain in your butt. I don't know, right? Your logistics are not universal. What are your security needs? Do you need, role-based access control? Do you need, specific guarantees about data privacy, and the information that you collect on users? Different systems and different frameworks are going to have different abilities there. What skills does your current team have, and what can you hire for? So if you are, building your own machine learning system from scratch, you're going to need some machine learning engineers. Can you hire them? Do you have them? If not, you might want to take another approach. How much of a maintenance burden can you take on? So again, imagining that you're building your own system from scratch, that's going to have probably a bigger maintenance burden than something that you are building based on an existing framework that another team maintains. Just again, something to consider for the longevity of your project. And everybody's favorite, what legacy systems do you need to integrate with? So just a fun story here. So my mom was also a computer programmer. And every so often she'll get support requests for systems that she built long before I was born that are still in service. So I don't know. It's good to really think about how flexible a system is, what it can integrate with, whether it can integrate with the things that you need it to integrate with for your specific, situation. And like, best for you is not necessarily going to be best for somebody else, even based on your, your machine learning and your data needs based. Y'all get what I'm saying. Logistics. All right. So quick review of what we talked about today. We talked about the problem. Is it a chatbot problem? We talked about the data. Do you have the right data, enough data? Can you get it? We talked about learnability. Given your data and your problem, do you have the ability to solve your problem? We talked about model selection. So given a bunch of different models, which one's going to be most relevant for your data? Well, you're probably going to have to guess and test. Like someone with a lot of experience can sort of, you develop intuitions, right? And I can say like, oh, this type of problem is a good application of transformers, or like a specific type of transformer, or this type of application is a really good, good place to use regression or something. Well, I could make more theoretical guarantees about regression than I can deep learning, but picking the model, there's going to be some guessing and testing. Prepare yourself for that. And finally, logistical needs. What works with your setup, with what works for what you're building with, and that depends on you. And then, I got to talk about Rasa a little bit in more specifics. So some things that if you are trying to build a chatbot and you're like, is Rasa the framework for me? It might be. Some things that we really focus on. So are you building a chatbot to complete a specific task? So Rasa was built for building task-oriented dialogue systems. If you need an open-ended chatbot that can just do chit-chat on any topic, we're probably not the right choice for you. I'd probably do something else. Do you need to do a lot of customization? So do you want to train all of your own intents? Do you want to train all your own conversational paths, your NLU, your dialogue policies, etc.? Do you need that? We're great with that, right? We're open source. You can get in the internals. You can mess as much as you want. With that in mind, are you looking for open source? Is that something that's important to you? Is that something do you need to be able to go in and mess with the internals? If so, we got you. Are you going to need to integrate with code? So different frameworks will have this ability to a different degree. For us, it's very foundational and very flexible. So if you've used Rasa before and you've used custom actions, basically this is code that is triggered at certain points during the chatbot that you write and provide and lets your chatbot do things. I think that's a good explanation of custom actions. Are you looking for a framework that is human language agnostic? So we don't assume any particular language. Our tokenizers, you're probably going to need to adjust a little bit, but the default pipeline should work for most white space tokenized languages. Somebody asked about this recently. So with Diet, which is one of the components in our pipeline, we will train embeddings based on your provided training data. So if you have a language that you want to provide your own NLU for, or you want to be able to work with that other places don't support, we might, I don't know, could be for you. And then finally, are you looking to host yourself, or are you looking for really flexible deployment options where you're, we don't do deployment, right? We help you build the chatbot. Yeah, so if that sounds like you, maybe Browse is the right choice for you. Maybe a different chatbot framework is the right choice for you. It depends. And I can't just like sit down and give everybody a single recommendation because I would be wrong about at least some people. It depends. One last time. But the things that it depends on are, I hope that this has given you a good set of things to think about and consider when trying to figure out what sort of chatbot framework is going to make the most sense for your problem. And of course, the most foundational question, do you need a chatbot? Are you sure? Like they're great for what they're great for, but a chatbot that you don't actually need is worse than nothing. Anyway, So that's about everything that I had for today. I hope this was helpful. I know it's a lot of like kind of vague high level stuff, but particularly when it comes to model selection, like that's the state of the field, man. I also wish that there were a lot of theoretical guarantees about the performance of specific models under specific situations, but there ain't. I don't know, maybe in like 10, 15 years, we'll have a lot more information on that. I certainly hope so. So I hope you found this helpful and illuminating. As always, if you've got any Rasa questions, you can head over to the forum. It's linked below. I believe it's forum.rasa.com. We will be back next Friday for another live stream. There will be no office hours on Wednesday because we're having our company offsite, so nobody's free, including me. So I will see you next Friday. I hope you all have a wonderful weekend. Stay safe, stay healthy, and I'll talk to you soon.